Alright guys, today we're going to solve a calculus problem from chapter 4 involving integration. We're going to solve number 38, which is ask us to find, the goal is to find the area under this inverted parabola by integration, or using integration. So here's our function given. We're going to simply use the fundamental theorem of calculus to integrate this function with the power rule here and evaluate what this area under this curve is. So to set up our integral, we first say the area is equal to the lower limit to the upper limit of integration. So negative 10 to positive 10 of integration, for limits of integration. And then we have our function 100 minus x squared. And then dx tells us we're integrating for this problem with respect to x for both parts of this integral. So we apply our rule for constants. When integrated constant, we know the integral of 100 dx is simply going to be 100 multiplied by x. And then use our power rule here. Here it's x squared, so n is 2, which tells us we're going to have minus x cubed over 3. Add 1 to the 2, so we get x to the 3, third power, divided by 2 plus 1, which is also 3 again. So we have x cubed over 3. Okay, we have to keep our limits of integration here. So we had from negative 10 to positive 10. Alright, and so I'm going to drop down a line here. I'm going to just work this out by hand. We can use the calculator at this point after we plug this in. So we substitute this in. We know we're going to get 100. Alright, multiplied by our first upper limit integration, that's f of b right here, which is 10, minus, we have upper limit integration again, f of b, which is going to become 10 cubed divided by 3. That's for our f of b. Then we minus our f of a, the lower limit of integration, substitute into this expression for our integral. So we have a similar looking part here where we're going to get 100 multiplied by negative 10 in parentheses. Okay. Minus, we have again negative 10 cubed divided by 3. Okay. And so this is now our answer. We just need to simplify this and we'll work that by hand. So I'm going to have the area is equal to, this becomes 100 times 10, which is 1,000, minus 10 cubed, which is also 1,000, but it's divided by 3. Okay, minus, here we have 100 times negative 10, which becomes negative 1,000. And then negative 10 cubed is negative 1,000. This negative sign out front makes this positive, or plus 1,000, divided by 3 still. Okay. So now, simplifying it on this step, we can go ahead and combine this 1,000 and this negative times negative is positive 1,000, so that becomes positive 2,000. Then we have negative 1,000 over 3 minus positive 1,000 over 3. So that becomes negative 2,000 over 3. Okay. We can then factor out the 2,000. And we have 1, well, it's multiplied now by 1 minus 1/3. Both these multiplied by 2,000 here. Okay, 1 minus 1/3 is 2/3, so it's 2,000 times 2/3. 2,000 times 2 is 4, so it's 4,000 divided by 3. Okay, we can check this now on our calculator just to be sure. Alright, we go to math and then FNINT for integration. We're going to integrate our limits from negative 10 to positive 10. We just type in the integral as we see it in the original problem. 100 minus x squared, and then we're integrating with respect to x. And we get 1333, which if we convert to a fraction is 4,000 divided by 3. So we can see here we got the correct answer. We checked in the calculator and we can see this is the area under this curve according to the fundamental theorem of calculus.